This is a joint we use a lot in the magazine. It's some people call it a locking rabbet construction drawer. Some people call it a rabbet and dado. And there are actually two different versions of this as well. What we're basically doing is we're going to put a dado in the side of the drawer at the back and the front, and then the piece that goes into that, we're going to cut a rabbet. So this is a side. I already have one of these dados cut. We have to cut the dado in the front. Then we have to cut rabbets in this piece to fit. So this can go together really, really quick. It's actually a good mass production drawer if you can kind of keep all your parts machined accurately. So we'll start with that. So this style drawer has, we won't worry about the bottom yet. This would have a false front on it, meaning you're sizing this drawer to go into an opening. Right now I'm just worried about building a square drawer. We're going to put it in the opening, and then later on we're going to slap on a front. It could be an overlay front where it covers the whole frame. It could be an inset front where we're fitting it inside the opening. So right now we're just trying to get a box that's quasi-square and resembles a drawer together. So a couple things I've done on this. I've already milled the groove in the back, and I'll actually talk about what's going on with that later. Now we got to mill the groove in the front. So over at my table saw, I have a 1/4-inch stacked dado set up. So this is just the two outer blades of my stacked dado head. And this is usually when I start machining drawers, this is what I like to have in it constantly. I'm not adding or deleting any spacers in there or any extra chippers in there. I'm just wanting to run at a 1/4 inch. So if I need to make something wider than a 1/4 inch, I have to take more than 2 cuts. But typically it's just raising or lowering the head or moving the fence just a little bit. So let's get started with this. Okay, so I want to cut this to a depth of a 1/4 inch about. And this is something I really like to set up my my saw. It is a Veritas. What's really nice about this one is the outer, well, I should explain it this way. This is all 16ths, this is all 32nds. When I turn it over, this is all 32nds, this is all 16ths. So it transfers from one side to another. If I want to be super accurate, I can put 32nds here. If I'm comfortable with, you know, like here I'm trying to hit a 1/4 inch, I can put my 16ths side up and I can hit that. What I'm going to do, I usually measure off the side of the left side of the blade. My left side, your right. So I'm going to look for a sharp point, put this down next to it, and just set the tooth height off my square. And what I'm doing here is I'm just moving this back and forth to find the high point of the blade. Different saws have different spots within the throat plate where your high point is going to be. Some saws, your high point is actually in the back third. Some it's right in the middle. Rarely do I find it's in the front half. But this needs to go up just a little bit, and I'm happy with that. So I'm going to lock that in place. Next thing I have to do, so I'm going to cut a dado in here, which is just a groove across the board, 1/4 inch deep, and now I need to set my location for where I'm going to cut it right here. To set that location, I'm going to use this is actually the front. So there's my sharp tooth again. I'm going to move this over. Actually, I'll do this where you can see it a little better. And I'm going to bring this right up. So what I've done is I've set the groove back the thickness of the drawer face, or the drawer front. I've set the groove 1/4 inch high. All I have to do now is make sure I don't have anything in between my fence and my workpiece. Move this over. Oh, pretty good. I'm not dead on, but pretty good. I will show you. When you're doing this at home, don't be like John. Actually test it on a piece of scrap. I have just this is a cutoff of this stuff. So it's always nice to have, okay, before I commit myself to this cut, try it on a piece of scrap. Make sure it fits before you machine everything. So for this, let's say on this drawer we don't have this weird thing going on the bottom. We're just starting out. What I'm going to do is cut these dados, do it on all the drawers. And then depending on the style of drawer, if your backs go all the way to the back, all you'd have to do is flip this around and cut those dados as well. On this style, I want a little bit of an anti-tip, so I moved them up. So at this point, I would have to move this over, cut these as well, and then I can move on to the drawer fronts. So my fronts are actually a little bit more than a half an inch. They're just a little bit thicker than that. So I know my blade height is at 1/4 of an inch. I pretty much don't have to worry about going over right now. So I can set this up to cut a rabbet. So to cut the rabbet, I'm going to put in a sacrificial fence, or sometimes I'll call it a zero clearance fence, something. So what I use to hold this on, you could just grab a board and hold it on with a couple clamps. I really like these guys. All you have to do is drill a couple of holes in the top of your sacrificial fence, and this drops in, and you have a nice, clean surface that, with no obstructions, that you can kind of cut all day. Okay, so I'm going to move this over to just the edge of the teeth. Okay, and then I'm actually going to use my my practice board here just to dial it in before I start going crazy. So I know this isn't going to go in. It's going to be a little bit tight. All I have to do is raise the blade just a little bit. Okay. If you're doing this at home, machine all these grooves on the sides first, then worry about the fronts and the backs, and that's kind of the order of operations for mass production too. What I've left out on these are the grooves in the bottom, and I typically do that last just because as you mill this up, certain things can happen. You can have a little bit of tear out. You can forget what goes where and just start cutting things in random places. On these boards, you're really not going to get wrong where the rabbet goes. It goes on the ends. So that's pretty self-explanatory. With these dados, it really doesn't even matter where you're putting them, whether it's tight to the front or there's a little offset in the back. You're probably not going to get them wrong. At the very, very end, I cut the grooves in. Sometimes I'll even rough assemble the drawer and just get it together like this, and then go, okay, I need to cut grooves in the bottoms of all of these. So this side goes against the fence. This side goes against the fence. So as I'm standing, this will be on the fence side, and this side will go against the fence. So one at a time, or if you're just running a small batch, you can kind of rough assemble them, set them out, and go, okay, don't do this. We're going to keep all our parts straight. If you're mass producing them, where you're just sending them in batches, about the best way is to have stacks where you'd have all your material stacked up, and you want to keep it in that orientation where you pick it up and go, okay, I don't want to start turning around and doing this on the wrong edge. I take this, and this is going to run against that without turning it around. So let's run the grooves on these quick. This is front, so this will go just like this. Oh. Yay. So on this one, the bottom slides in from the back. Just like that. Might have to do just a little bit of sanding on that plywood to get it to go in smoothly. If you have undersized plywood, then the bottom becomes more problematic. You're probably going to have to do 2 cuts with a regular saw blade rather than a dado set, just to get that to go together. Also, you might notice the top of my drawers, we have some issues with some height discrepancies, and it doesn't look good at all. These are actually cut way higher than I need them to be. These sides are well over 8 inches tall, and I only need a 7-inch drawer. Part of my rationale is I did this on purpose. I have these rough edges that if I didn't have this on the bottom to tell me what's going on, I know when I get over to the saw that this rough edge against a fence, something's wrong. This means don't cut grooves up here, cut grooves down here. So it's just my little way. On this one I have a squiggle. On this one I have a defect there that's going to get cut off later. I don't put the whole drawer together and then start cutting around the outside. Typically before I do my final assembly, I'll go over to the table saw, rip this down to the size I think I need, and then go from there. Now, as far as fitting this, figuring out how big of a drawer we need to have, typically we try to build the case first and then we measure the opening that it's going to go in. For width, I usually subtract 1/8 of an inch from the sides. So you'd have a 1/16 to each side, and this is a drawer that it's a wooden drawer that goes in a wooden opening. And then I subtract a 1/16 to 1/8 of an inch for the total height as well. Now going from that, I have a drawer. I have to do 8 of these drawers. They're 7 inches tall, and they're deep, so they can hold some weight. I need a nice strong drawer that isn't going to fall apart and isn't going to wear out either. I know that the material in this is rather soft. The case that this goes in is going to be cherry. So after a few years, I'm probably going to start seeing little white sawdust fall out of my piece because I have all that weight and it's actually wearing the wood away. So that's why I put these wear strips on the bottom. On this particular one, I used white oak because I have white oak. And another good alternative would be to use like hard maple. That'd be something hard that slides easy. I've gone a little extra here where I'm sure you've seen on the drawer I passed around. It sticks out the side. It's tongue and grooved into the drawer side. You could just glue on a 1/8 inch wear strip on the bottom if you really wanted to. Another strategy is just make it out of whatever you want. And have you ever seen the drawer glide tape at all? It isn't blue. It's actually clear. The blue is the backing. So this is that glide tape that you can usually I put on the case. So pass that around and it's you're like, oh, it's a strip of it's basically overgrown Scotch tape. It works wonderfully. With a lot of use, it does wear out, but you just put another strip down, and as long as you have a drawer with it in it, you're fine. And I know with these. This set of drawers, this wood, it's not going to be the strongest drawer in the world. It's not going to be heavy. And the wood is pretty stable, but I have everything in these drawers from quarter sawn grain to flat sawn grain, a little bit of rift sawn, and maybe that's all in one board. So I don't want to take the chance of this thing swelling up vertically. I don't want to take the chance of it swelling up side to side. So this little runner keeps all of this away from everything in the case. I can run this almost tight to the case, and if I have to make any adjustments, all I have to do is shave off a little bit of this. I don't have to touch the side at all. Typically, if I am in a situation where the drawer swelled up or the case moved and I can actually get it back out of the case, I'll actually taper it from front to back a little bit, either by planing or sanding aggressively. So maybe I'll take a 1/16 off the back and feather that out to 0 on the front, so the front stays pretty tight, but then it's almost wedge shaped. So as you push it in, it doesn't jam in the opening tighter and tighter and tighter. Same with any adjustments up and down. I'll leave the top as tight as I can, and then if I have to, I'll cut the back down at an angle so you can actually get it in there.